like most emerging markets and overnight successes, they've been around for a long time. And let's see if we can show you some just little bits of information, some background information on indoor. Let me just call it indoor as opposed to a little more targeted mobile mapping kind of adventure. Indoor mapping, of course, has been around for a long time. Kevin, 30 years ago, was doing it. What was it? 15 years ago. There we go. It's not quite that old. But the building information modeling market is expected to reach $6.5 billion worldwide by 2020. So we have a lot of big companies that are out there that understand the nature of BIM. So BIM is building information modeling. That's one of the key big segments for indoor mapping. For 3D laser scanning, there's been a lot of different segments for indoor mapping. So complex mechanical process plants, that's been around for a long time, for stationary terrestrial mapping, things of that nature. And so that technology is kind of undergoing a little bit of a revamp with some of the indoor technologies. Also in our industry, we have industrial plants. There's some niche segments for industrial plants that are out there. The building information segment is really quite powerful, and this will be an area where you will see a lot of innovation. So there we go. In terms of overall historic approaches to this, let me just quickly show you a video. So before we can go inside, we have to start at the outside, and this is more of a tripod scanning approach to this whole thing. We have, with our mobile systems, of course, brought that up, but these are some of the key segments, and there are clients here in this room right now that are using literally the same technology to be able to measure buildings, not only on the outside, but on the inside. So this particular sensor that you see here, you've got sensor number 1 is the LiDAR scanner, sensor number 2 is a calibrated camera, sensor number 3 is a GPS antenna, sensor number 4 is an internal digital compass, sensor number 5 is, there's then additional inclination sensors that are built into this. So what you have here on this tripod is a very sophisticated multi-sensor array. And GPS was one of the key aspects for mobile scanning, but when we move indoors, as Kevin indicated, we leave that GPS behind, and we've got to figure out other ways to make that happen. And there's been a lot of innovation in this lately. So here's the point cloud. This is what your people in the field have to go get. They have to scan, acquire, get the point cloud, get it perfectly geo-referenced, run a QA/QC on it to make sure that it's okay, and then it's ready for some feature extraction detail. So here's that. This is a common software package found in Europe. Here in the States, there's Ted Mack at Certainty 3D has got, it's called TopoDot, and it sounds like it's simply for the transportation infrastructure market, but he's done this kind of work for years, and his software plays to this rather dramatically. So this is a 3D solid model then that's visible in CAD, and so then let me go to another segment here pretty quickly. That's all cool. Okay, so within Europe, what's typically common are historic buildings that need to be measured and things of that nature. So this is an example, once again, from Vienna. This is, I think it's Karlskirche, right off one of the central squares in downtown Vienna. So here's the exterior of it. There's a lot of sensors that are on the marketplace right now that can do this. A couple that come to mind are, of course, the Regal. Leica has a superb instrument that's out there. Trimble has got a product that can do similar things to this. They're marketing the Faro scanner. The Faro scanner typically is a little more suitable to indoors, so now boom, we go indoors. And what you're seeing then is the indoor segment of this map. It's a little grainy on the screen, but you can see it. There's the technology at work on the indoor. And so it's photorealistic in the point cloud, so we're colorizing the points. But the photo images now are just the beginning for a lot of changes that are taking place in indoor scanning. So, you know, this is, of course, spectacular. This is basically what can be done with stationary territory terrestrial systems applied to the indoor. Okay, now, let me just jump around a little bit, go to just a bit of a resource for you. The U.S. General Services Administration is, I believe it's the largest landlord in the United States of America. They contract out, I don't know the specifics of it, but millions of dollars of indoor mapping utilizing 3D scanning. They have, this is available on the website. This is their GSA BIM guide for spatial program validation. So you want to get up and operating and into this business. How do you do this? How do you go about it? Do you need to have an indoor mobile mapping system? No, not necessarily. There's other ways and other paths and other methods. But if you do want to get in this, you want to know about these guys because these are, you know, these folks here are contracting out to have their buildings measured so that they can be managed. If you can't measure it, you can't manage it. So this BIM guide does a wonderful job of identifying the requirements, of laying out how they expect things to be handled, things of that nature. But as in all contracting scenarios, it also helps to have a little experience in this background as well. Then, let me try and bring up a better one here. So, this is a little picture. This is R&D, okay? So, we just saw that same stationary terrestrial laser scanner on a tripod, and so now what happens when we go indoors? I kind of like this particular picture because it's from an R&D facility in Japan, but they've got a little fun with that Tyrolean dwarf in the lower left-hand corner. They're making fun of the German optical electronic equipment that they're purchasing. So, yeah, a nice sense of humor that the Japanese have. They're quiet, but they are humorous. But what you're seeing here is a couple different laser scanners. You've got some 6 scanners down front. You've got the Regal scanner. There's video systems on here, robotic systems that move throughout the building, things of that nature. And what's kind of cool about this is, and we don't always appreciate it in this room, the folks that do R&D really spend a lot of money, time, and effort to go down blind paths and to gather those little nuggets that we don't have to spend time, money, and effort going down, spending money, and hitting blind alleys. So this is kind of cool. Lots of technology and lots of sensors arrayed on this thing, but all of this is getting simplified for you to be able to pursue some of these markets. It's gotten quite a bit simpler in the past years, and there's been a lot of more activity that's taken place here, and there are some other resources that are out there. This is a paper. This is available from SPAR, and this is the Point Cloud Library Accelerating Growth of Real-Time Dense 3D Applications. So a lot of this is indoor stuff. There's our old friend, Ken Spratlin, the Director of Innovation for Trimble Geomatics. This is associated with the Point Cloud Library. I'm sure a lot of you haven't heard about it, but it's one of the powerful new tools that's emerging out there, right? So historically, how have we done things in this segment? We've set up a tripod scanner, captured the scans and photo information where it's georeferenced in the world, and we take that, do a QA/QC on it, and then typically we export it out to a package like Certainty 3D has, and then we begin the feature extraction. It's all done in CAD, and we deliver that CAD product, things of that nature. Point Cloud Library has a little bit of a different perspective, so globally there's a lot of efforts with having all of this data available in the cloud, right? So we'll hear some talks about this a little bit later this week. Probably one of the most effective ones that's out there is used by the military. It's called the GRID, the U.S. military. the grid, so the grid's very, very cool. It'll take multiple data sets into the cloud. They all have different error models associated with these data sets. Some are 5 meters, some are centimeter level, and everything in between. And they've got the error models and the algorithms developed to be able to resolve all of this data together, so that all you do is you grab your little cursor and pull out, for instance, Kandahar over in Afghanistan, and then boom, all the data and information is available to you there, and you can send out point clouds of all this combined data to different people. Point cloud library is kind of moving down that path. Esri also has an effort. So this particular document is available. It's lengthy. It covers tons of information, and so there's lots of different things. The Microsoft Connect Fusion is discussed in here. I'll talk about that when I try and wrap up here in a few minutes. The power of that and where that's going. Point cloud libraries, open source models, robots that are used, large scale mapping, classification methodologies, obstacle detection, things of that nature. Very, very powerful. And great information. So if you are going to do R&D and take a look at this particular marketplace, this is one of those documents that you want to go back and look at. There's I could have brought up a number of examples of how folks have used this. This particular one is also available from SPAR. It's fairly neutral. It's Brian Elb from TrueScan 3D. He's got some pretty cool stuff that's out there. So he did with Revit. He did an analysis of this older historic building from the outside and the inside. And Revit is one of the popular end-use packages. If you're not familiar with Revit, it's owned by Autodesk, and it's for BIM and for 3D point clouds. Revit is one of the popular destinations for deliverables and end-use packages, things like that. So this, I'm not going to go into detail on this, but he covers this really nicely. The different towers, elevators, different floors, things of that nature. Bear with me here. I just want to run to the end to grab a little visual for you. Let's see. Let's do this. So there's some of the point clouds, some of the feature extraction that's taking place. And here's the model in Revit. At the top level, you're seeing another side shot, and then the whole solid model. And within Revit, they were able to integrate this entire 3D model within Revit. Now, that's pretty impressive. Revit, in my experience, hasn't been able to do that a whole lot. So then another example of some folks that are out there doing some work is a company out of Pittsburgh called All Point Systems. So they've got some mobile solutions that are out there. So they're throwing 3D scanners. They've used quite a few different 3D scanners out there. Faro is one. They've used ZNF. They've used the Regal scanner to do this. So they've gone through and kind of integrated all of these things, thrown them on little robots, and they've solved a lot of the problems with targetings, registration, QA/QC, workflows, things of that nature. So very, very, very powerful. These guys did great work. Don't mean to cut them short, but it's very, very nice stuff. There's some advanced methods of using deviation analysis to be able to do QA/QC on projects. I'm getting deep in the weeds here, this is stuff that Terry, for instance, might find fascinating. This is stuff that Ted Knack is going to read at night to be able to assess QA/QC methods for his software, things of that nature. Once again, it's the gurus out there in the R&D world that are going through and doing the analysis of this stuff, and they're all moving to the mobile